Alright, in this problem we're asked to solve tangent of x plus radical 3 equals secant of x over the interval of 0 to 2 pi. I like to draw a line down my equal sign. I like to rewrite the problem again so that I know what the original problem is. Someone mentioned we're going to use some identities. Some people mentioned that we're going to use a Pythagorean identity, but the Pythagorean identities have powers of 2, so we're going to have to raise your hand if you squared both sides. Is that okay to do?
Yeah.
It's an equation. So on this side, I'm going to have secant of x squared. And then on this side, I have two of these expressions, right? So I'm going to do a side problem. This is essentially tangent x plus radical 3, tangent x plus radical 3. If you want an automatic F on your test on a problem like this, you'll probably just square the tangent and square this and get tangent squared x plus 3. That would have been incorrect. Here you have a binomial times a binomial. I teach my students to use the box. You don't have to use the box, you can use FOIL, doesn't matter. So this is tangent of x, and you have plus radical 3. Class, what's tangent times tangent? Tangent squared x. Remember, just think of it as without the trig function, right? Tangent x times radical 3. Radical 3 tangent x. Tangent times radical 3. Radical 3 tangent x. And radical 3 times radical 3 is? Radical 9, which is 3. So pretend it's, again, like there is no tangent, no trig function. You could just do x times x, x squared, x radical 3, x radical 3, radical 3 times radical 9. Radical 9, which is 3. Okay, so if you have something like this, radical 3x plus radical 3x, just think of it as x plus x. You're just adding what's in front. So you have a coefficient of 1, so that's essentially 2x. Or in this case, this would become 2 radical 3. So my answer here is tangent squared x plus 2 radical 3 tangent x plus 3. So that becomes tangent squared x. Here you're now combining like terms, so we're adding. And just the coefficient in front. There's 2 radical 3 tangent x, and then you have the plus 3, and then this is secant x squared. Class, secant x squared becomes what? One plus tangent squared x. Class, what's the reason why I can do that? A Pythagorean identity. So you should always be thinking, well, are they the same trig function? If they're not the same trig function, can I actually make them the same? Well, we have identities that you can do that. I'm just going to bring this down. Tangent squared x plus 2 radical 3 tangent x plus 3 equals 0. Can I just move everything to one side? Can we do that? So I can subtract tangent squared x. let's do that and see what happens. These will cancel. These will cancel. We're left with 2 radical 3 tangent x plus 3 equals 1. What should we do next? We'll just subtract the 3. What are we left with?
-2.
Almost there, right? What's next?
Divide.
Divide both sides by 2 radical 3. Remember, this is -1 times 2 radical 3. So my next line, I can have tangent of x equals, what can I simplify over here? So we have a -1 over radical 3. And then I'm going to rationalize. So I have tangent of x equals negative radical 3 over 3. Now, you're going to take the inverse, right? So I have the inverse of tangent of negative radical 3 over 3 equals x. And we're trying to find x. Now, I gotta look on the unit circle where tangent's negative, but before I do that, do you guys remember how this is a good clue right here? Do you see that in yellow? Because do you see a positive or -3 on a unit circle? Do you guys see that? No, so it's kind of like we need the steps before. So a lot of times you're always complaining, I'm just doing the problem so long, right? But you actually appreciate it because you actually understand the math that's happening, right? So here, if you ever get an answer like this, you can just multiply it by radical 3 over 3, and it'll give you this one. Why do you want something that you have to rationalize? Like, Mr. Ring, that's not simplified, but at least this tells you that tangent is which two sides? Y over x. So I'm going to look for y values that are 1 and x values that are radical 3. So I need where tangent is negative. Put your 2 fingers on there. Which 2 quadrants, class?
2 and 4.
2 and 4. Now I'm looking for a y value that's 1 and an x value that's radical 3. 5 pi over 6 and 11 pi over 6. Right? 1 over radical 3, it'll become negative. 1 over radical 3 becomes negative. So 5 pi over 6 and 11 pi over 6.
What was that?
Now, because we did something here, because we squared it, I actually have to check my solutions. These aren't my final answers. What does that mean? I'm basically going to take each of these answers. I'll make one green. I'll make one orange. I'll pick another one as well. I have to actually test both of those solutions to make sure they're not extraneous. What does extraneous mean? Yeah, you think you have an answer, but if I actually plug it in, let's see if it works. So let's go ahead and put in 5 pi over 6. Tangent of 5 pi over 6 plus radical 3, is that equal to secant at 5 pi over 6? Tangent at 5 pi over 6, we were just there, is negative 1 over radical 3. Or if you rationalize it, we already have it above, it's negative radical 3 over 3. Plus radical 3. And is that equal to secant at 5 pi over 6? So secant is which two sides, class? X, Y, and R? R over X. So I'm going to need to find cosine and just take the reciprocal. So 5 pi over 6 cosine. So I'm going to have, I have to take the reciprocal of that, so that's negative 2 over radical 3. If I rationalize it, I get negative 2 radical 3 over 3. On this side, I'm going to make it a fraction by putting over 1. I cannot add these because I have a common denominator, so I can just multiply by 3. I get negative 1 radical 3 over 3 plus 3 radical 3 over 3. And all I have to worry about is the coefficients. Negative 1 plus 3 is what? 2 radical 3 over 3. In class, are these equal? No. One's positive, one's negative. Which tells us that 5 pi over 6 is not a solution to the original equation. Let's go ahead and test 11 pi over 6. And do the same thing. Tangent 11 pi over 6 plus radical 3 secant of 11 pi over 6. Use your unit circle. Tangent 11 pi over 6, we already have the numbers. 1 over radical 3, which is negative, and you can just rationalize it, so it's the same thing as over here. And then we can kind of already speed up the process. We already know that this is radical 3 is just going to become a 3 over radical 3. And this will become just a 2 radical 3. Secant at 11 pi over 6, R over X, that's a positive 2 over radical 3. Rationalize it, I get 2 radical 3 over 3. Class, are those equal?
Yeah.
So this is equal, so it means our final answer is 11 pi over 6. I know what you're thinking. The problem's long, and then the question, do I have to show all the work? The answer is?
Yeah.
Yes. So in this problem, we took our trig functions, we made them the same by using the Pythagorean identity. Once I have the Pythagorean identity, and we expanded by using the box, we got 2 solutions. Those 2 solutions you have to test back into your original equation.